Students, I'm going to teach you some numericals in micro. This one is for perfect competition. I have done it before. I'm just repeating it again for you, for those who missed the class. So I'll start with the perfectly competitive market. We know how is profit maximization done under perfect competition. The first order condition should be price equal to marginal cost, price is equal to marginal revenue, this should be equal to marginal cost. And second order condition is that the marginal cost should be rising at the point of equilibrium. Here R equal to Px. This is a straight line passing through origin with the slope P. Profit is equal to, here profit is written as a function of X is equal to R revenue as a function of X minus cost as a function of X. So this R as a function of X, you substitute this Px, it becomes Px minus Cx. So if you take the derivative with respect to X, pi prime X equal to P minus C prime X. So this will be equal to 0. The C prime X is equal to marginal cost. So price is equal to marginal cost. That is the necessary condition. Second order condition, this pi double prime should be less than 0. Now, what is pi double prime? Differentiate this with respect to X again. You are left with 0 minus C double prime X. This should be less than 0. Now, minus C prime, this minus sign says that this whole thing, term minus C double prime X is obviously less than 0. So if this condition is to be fulfilled, supposing this C double prime X is equal to a negative thing, then this minus minus will become positive and it will become greater than 0. So this C double prime X should be positive, should be greater than 0. Otherwise, if this is less than 0, minus or minus something will become positive. Okay, it will be greater than 0. So we have to make sure that C double prime X should be positive. Now, what is C double prime X? This is the derivative of marginal cost with respect to X. Okay, when X increases by a very small unit, by how much marginal cost changes, that will give you this C double prime X. So this should be greater than 0. That means the marginal cost must be rising at the stationary point. What is this stationary point? The point of equilibrium here. We mean the point of equilibrium here. Okay. We have a question here. A plant produces X tons of steel per week at a total cost of rupees 1 by 10 x cubed minus 3x squared plus 50x plus 300. If the market price is fixed as rupees 100 by 3, find the profit maximizing output of the plant and the maximum profit. Will the firm continue production? This price equal to 100 by 3, revenue equal to 100 by 3 into x. This cost is equal to 1 by 10 x cubed minus 3x squared plus 50x plus 300. So the profit will be equal to R minus C. This is equal to 100 by 3x minus 1 by 10x cubed plus 3x squared minus 50x plus 300. So if you put this thing here, minus 1 by 10x cubed plus 3x squared minus 100 by 3x minus 50x plus 300. You can write it as 100 by 3 of x, or you can write this as 100x by 3, which means the same thing. Okay, so you are left with minus 1 by 10x cubed plus 3x squared. This whole thing comes together, 3 5s are 15. 100x minus 150x divided by 3 will be equal to 50x by 3 plus 300. Okay, for maximum profit, you take the derivative with respect to x. You are left with 3 by 10 minus 3 by 10 x squared plus you are left with 3 2s are 6, 6x. Here you are left with 50 by 3. This would be equal to 0. So this whole thing you take 30 here, 10 3s are 30, 3 3s are 9 minus 9x squared plus 6 10s are 6 here 30. Below here you have 1 here. 1 into 30 is equal to 30. So 30 into 6 you get 180. 180x plus here 3 into 10 is 30. So 10 into 500, 50 is you're left with 500. Okay. I'm making one small mistake here again. I keep making the mistakes. I'll just change this. So this should be minus 9x squared plus 180x minus, it should be minus 500. Okay. Minus 500 equal to 30 into 0. You put this 30 here. 30 into 0 is equal to 0. So here minus 9x squared plus 180x minus 500 equal to 0. You're left with that. You can further simplify it. Multiply both sides by minus 1. You're left with minus 9x squared minus 180x plus 500 equal to minus 1 into 0 is equal to 0. Okay. Using this equation, you can write a formula for a quadratic equation. X equal to, there was one mistake in the formula. I've changed again. That's why I was confused. I got stuck here a little bit. So x would be equal to whole thing is minus b plus minus square root of b square minus 4ac divided by twice a, whole thing divided by twice a. That's how you get 180 plus minus. You'll find that this whole thing is equal to 14400, which is the square of 120. 120. So you take the square root, you are left with 120. 180 plus minus 120 by 18 is the result. Okay, so x can be either of two things. It can be 180 plus 120, in which case it becomes 300, 300 by 18, or x can be equal to 180 minus 120 by 18, which is equal to 60 by 18. So x1, you have written the first value of x could be x1 equal to 300 by 18. You can simplify it to 50 by 3. X2 is equal to 60 by 18. You can simplify it to 10 by 3. Okay. Of these two, the one you are going to choose that one which fulfills the second order condition. Okay. So this is the formula for solving a quadratic equation system with the form ax square plus bx plus c. X will be equal to minus b plus minus square root of b square minus 4ac divided by whole thing divided by twice a. This is the formula. Second order condition is pi prime is equal to minus 3 by 10 x square plus 6x minus 50 by 3. Now, take the derivative with respect to x again. You are left with 2 3 are 6 minus 6 by 10x plus 6. Okay. When x equal to 50 by 3, you'll find that pi double prime equal to minus 6 by 10 into 50 by 3 plus 6. So you are left with minus 10 plus 6 equal to minus 4, which is less than 0. When x becomes 10 by 3, pi double prime will be equal to minus 6 by 10 into 10 by 3 plus 6. This is equal to multiply this will cut each other. 3 2s are 6. You are left with minus 2 plus 6 equal to 4, which is greater than 0. So obviously this does not satisfy the second order condition. Hence the second order condition is fulfilled when x equal to 50 by 3. So the profit maximizing output is thus 50 by 3. So the maximum profit pi equal to, you substitute, this is the formula for pi, which is equal to r minus c. You substitute the value of x here, minus 1 by 10 x cube plus 3x square plus 100 by 3 into x minus 50x plus 300. This is equal to minus 1 by 10 x cube plus 3x square minus 50 by 3 of x plus 300. So this is equal to minus 1 by 10 into 50 by 3 whole cube plus 3 into 50 by 3 whole square minus 50 by 3 into 50 by 3 plus 300. You are left with minus 207.41. The firm is incurring a loss of rupees 207.41. If it doesn't produce, its loss is the fixed cost 300. If it produces, the loss is only 207.41. That means it is able to meet its variable cost as well as a part of the fixed cost. So the firm will continue production. The firm has met its variable cost and is even meeting some part of its fixed cost. So that's all for today. I'll also record again. Bye.